Another type of solving a word problem using an exponential equation type 2. And even though this is in the same ALEKS type of problem, it's enough different that we might need to talk about it with a little different strategy. So let's look back at the problem in ALEKS. The computer laptop is purchased for $2,800. Now each year its value is 75% of its value the year before. After how many years will the laptop be worth $200 or less? Use the calculator, answers a whole number. So what we have here is a situation that doesn't exactly fit the compound interest formula. That compound interest formula is a kind of a specialized version of an exponential equation. Let's take a quick look at that. And we can see here that it's very specialized. We have this formula with these inputs and so on, specially for compounded interest. But let's instead take a look at a more generic way of tackling similar problems that's customizable for many different situations. And so in this case here, let's kind of run through what we have. We have a particular starting amount of something. We have the amount at time t, and then we have this base number. Now this can change depending on the situation, and that's what we need to talk about. T, of course, is time, and K is the amount of time for the base to make one cycle. So maybe I should summarize this in a few notes. So maybe these things will help. What I'm saying here is A is the amount of whatever we have at time t. A0 is the amount we have at time 0. B is this base. We need to talk about that. And K is the time for the base to make its cycle. So we could say things like, what if we had a bacteria that doubled every 3 days? Well, doubling then would be what's happening. The base would be 2. It doubles every 3 days, so that's the time that it takes to make one particular cycle. So that would be the situation. Sometimes we have these radioactive elements half of which decays, let's say every 5,000 years. Well, in this case our base would be a half, because that substance falls in half every 5,700 years, so K would be 5,700. It's hard here because there's so many different examples, but let's look at the one that we have in ALEKS, particularly in this case, and then go from there. Okay, we see here that the 2800 is our A0. Now each year its value is 75% of its value the year before, so this is our base, 0.75. After how many years will the laptop be worth $200 or less? So this is going to be our A. They're asking us for years, and then they're telling us that each year this value happens, so K is 1 in this case. And so we can size this up according to our standardized formula. Let's plug that in this particular case and get set up. So in this case, we will have 200 equals 2800.75 to the t. Okay, once again here, since this 0.75 happens every year, then that'd be once for one cycle would simply be 1 then. So the K just goes away in this case. Let's notice here that we can divide both sides by 2800. So we'd like to isolate this exponential term every time. So if we grab our calculator here, we're going to have 200 divided by 2800. Now notice that this is a nasty decimal that we'd have to kind of keep track of. Here's one of my favorite ways of dealing with this. Oftentimes see these decimals come out, and they're infinitely long. If we go with this value, it's been rounded at some place. Sometimes a better way here is to treat this as a fraction. So take this 200, can make that as a fraction over 2800. Now some of you may be able to see immediately that that is 1/14. I think I would rather keep that as a fraction because that's an exact value. So this 1/14 equals 0.75 to the t power. It's going to work out better this way, and I'll show you why. What we want to do now, as much as we did before, take the logarithm of both sides. So we're going to have the log to the base 10 of 1/14. We're going to have log to the base 10 of 0.75 to the t. Now once again, the magic trick of logarithms here, the third rule is to bring the t down front. So we're going to have the log of 1/14 equals t times the log of 0.75. Now it's going to be easy to solve for t. So t is going to be equal to the log of 1/14 divided by the log of 0.75. In fact, this is going to be way easy to put into our TI-30XS. Okay, and it's going to handle this nicely. So we're going to have a big fraction. In the top of that, we're going to have the log, and of course make a fraction, and that's where we're going to put that 1/14. Once again, I'd rather have a fraction than I would a decimal, because that decimal is going to be cut off at some point, and it isn't going to be exact. Fractions are exact, and we like that. And of course, we may round later. So what we're going to go in here and do is to take the log of your 0.75. Suppose I could have made that 3/4, but in this case, it's an exact fraction. It makes an exact decimal, so we're good to go. We're ready. Let's crank that. And here we go. We have 9.1735. Let's see what they want here. Now, we have to be careful, remember, in these situations, because they want this answer as a they want this answer to be put in as a number of years. And keep in mind here with this 0.75, we're going to have this decreasing exponential. The value continues to drop. So we're going to want to put that in as 10 years in order to get the answer. So that 9.17 number is going to round to 10, and we're good to go. Shall we look at one more of these? Okay, now we're back to a more of a compounded interest, so we'd want to just continue with that. This is ALEKS statistics solving a word problem, exponential equation type 2.